Hey everyone, and welcome back to the channel. In today's video, we're going to be doing a blinking LED example. I'll discuss the schematic, go over the code, and run the simulation. So, here's our schematic. I'm using Proteus simulator. For today's video, the main microcontroller is the PIC18F45K20. This is a 3.3 volt microcontroller. So what I mean by that is it requires a supply voltage of 3.3 volts. It cannot use 5 volts. We're using an external clock of 20 MHz with two 22 picofarad capacitors. So we're using pins RA6 and pin RA7 of port A. So you can see we've got port A arranged here, port B, C and D. So these are 8-bit ports. Then we've also got port E, which only consists of 4 pins. On pin RC0, which we're using as an output, we've got a yellow LED connected via a 55 ohm resistor. I'll show you how this was calculated shortly. And on pins RE3, which is the master clear pin, we've got VDD connected. So you could add a switch here to be able to reset the microcontroller if you want to. So the method in which I calculated the resistor value. So I went onto this one from DigiKey. It's called LED Series Resistor Calculator. Very simple calculation, but if you just want to use the interface here, I used a supply voltage of 3.3 volts. So that's the output voltage that would come out of the microcontroller pin. The forward voltage, as it's a yellow LED, I just used the maximum, 2.2 volts. It's always best to use the datasheet, but just as this is a simulation, I just want to show you how to write the code to just blink the LED. And the forward current, it really depends on the LED, but generally can be between 10 to 20 milliamps. So I'm going to go on the higher end. So you can see I've got 55 ohms. So that's how I calculated my resistor value. So you can see we've got two options here of interfacing the LED. We can source the current or sink the current. And what I mean by that is when we use the source current method, essentially the current is sourced from the microcontroller pin. So for example, in our case RC0, the current flows in this direction through the LED to limit the current, goes through the anode of the LED here, and then flows to ground. So in this method, we're sourcing current. If you want to sink the current, essentially the current is drawn from the VDD, or the 3.3 volt supply in our case, goes to the anode of the LED, then the cathode is connected to the 55 ohm resistor, and then the current is synced to the microcontroller pin. Now, you can also see that I've got a max 25 milliamperes written here, and that's the max capacity of the pins on this microcontroller. Not all microcontrollers can supply these currents, so please do check the datasheet and make sure your microcontroller can supply the current you request. So yeah, that's the schematic discussed. So if we go to our programming environment, I'm using MPLAB X IDE version 6.2. So what we want to do now is select File, New Project, Microchip Embedded, Applications Project, click Next. The device we're using is the XC8F45K20. We're using Proteus as the tool, so we can just leave that as no tool. Click next. We're using XC8 version 2.46. You can call the project whatever you like. I'll just call it T1. It's going to save it in this by default, so if you want to save it somewhere else, just click browse and redirect somewhere else. I'm going to set this as a main project and open MCC on finish. I want to use the code configurator, so I'm going to leave that checked. You can then click finish. So give it a few moments to load up MCC, which is the microchip code configurator. If you want to have a little loading symbols, then you can click this. Load symbols when programming or building for production. It just shows you how much space you're using in your microcontroller. So here we've got our content type wizard. So we want to go for classic content. Click here, click next. And just give it a moment to set up the project. So here we go, our interface is loaded up. So you can see we've got the package view here. It's showing the 40-pin PDIP package. You can also change it to other package variants if you want. So the first thing we want to look at is the system module. So if you remember, we're using a 20 MHz clock. So then we want to go to oscillator select, HS oscillator, system clock select as FOSC, external clock 20 MHz. We will need this for the delay function later. You can leave this as default. If you're using a PIC18, PIC18F4, and you don't want low voltage programming, so disable this. So that's all you need to do for the system module. We also need to set pin RC0 as an output. So we go to the pin manager grid view, port C, pin 0, and we set the bottom lock activated. So now that's set as an output. And you can see that's also reflected in this interface here. One last thing to do is an additional option if you want to, is you can give your pin a custom name. So I'm going to call it LED. And you can see it's set as an output. The last thing you need to do in this interface is click generate. Give it a moment or two. So now you've got generation complete. If you do have errors, for example if it doesn't generate properly, check the notification section just to make sure to find out what the issue is. So that's all we need to do here. So we can click MCC once to click it off. Go to projects, T1 or whatever you've called your project. We go into source files, main.c. So it's created like a default kind of a layout. So we've got some commented areas here, so you can give your code a name here if you want to. But essentially this is where the actual code starts. So we're including the necessary header files that MCC has generated. We've then got our void main function, so this is where the bulkier code will go. We're initializing the system, so we can have a quick look. For example, we're setting the pins, setting, for example, pin RC0 as an output, the oscillator, setting the clock as an external clock, things like that. Then we've got some default code which we don't need to worry about today. Then we've got the while one loop. So essentially any code that's put in the while one loop will continually run, it won't stop. So what we want to do is we want to blink the LED. So let's go and look for those pin definitions. So to do that, we go to header files, MCC generated files, pin_manager.h, But what we're interested in here is looking at our LED definitions. So you can see here we've got LED underscore trace, and essentially this allows us to set that specific pin as an input or output. So for instance, if you set LED underscore trace equals 1, then you've set the pin as an input. If you set it as 0, you set it as an output. So then for LED underscore lat, you'd use this when you want to write to a pin. So in our case, if you want to turn the LED on, as we're using the source current method, then logic 1 would turn the LED on, and logic 0 would turn the LED off. So in code that would be LED underscore lat equals 1 for turning it on, and LED underscore lat equals 0 to turn it off. And that's pretty much all you need to know for now. So if we go back to our code, so the first thing we want to do is turn the LED on. So in our case, you want to use 1 equals. When you use 1 equals, you're essentially assigning this value to this pin. If you use 2 equals, you're testing a condition. We're not doing that, so we're going to use 1 equals. Then we need to add a delay function, because without it, we won't be able to see the transition of the LED turning on and off. So we need to use underscore underscore delay underscore ms, open bracket. In our case, we want to use 1 second. So we type in 1000. 1000 milliseconds is 1 second. Then we do again LED underscore lat equals low. And we need to add an additional delay function. And that's all you need to do to blink the LED. So the final thing to do in this is to click clean and build main project. So if you get this message, you're good to go. So now we've got our project here, T1. You want to go into T1.x, dist, default, production, and we're interested in this one, the .hex file. So I'll just show you how to connect it. So if you double click on your microcontroller, go to program file, go on that box, and you can see we want to select our .hex file. Yeah. So if I zoom out, you can see now that our simulation is ready. So if I run the simulation, and there you go, our LED is blinking. Now if you want to, you can increase or decrease this value, and the LED will blink at a different rate. So that's it for today's video. Hope you found it useful. If you have any questions, let me know in the comments below. Source code and files can be found down below in the description. And till the next time, goodbye.